What is the most used man-made material on Earth? You guessed right, it's concrete. Look around. It's everywhere. Sidewalks, driveways, foundations, floors you stand on, and even entire buildings are made out of concrete. So why don't we discuss it more? In each episode of Concrete Logic, we will explore one concrete-related topic with the help from industry professionals that are shaping the future of the trade. We'll talk with suppliers, contractors, architects, engineers, specialists, and even some proponents of competing materials about their views of concrete and their vision of its future. And welcome to another episode of the Concrete Logic Podcast. And today I have Dean Kraft with me with ISC Logic Industries. Dean was on episode 36, which was fairly popular. I was sharing with Dean before we hit record. We talked about glue water. You would like, why are people are so interested in glue water? Well, we're going to revisit that topic today. That's why Dean is here. So you guys will learn about that. But before we get started, as I've been doing the last few episodes, just wanted to remind folks how you can support. So there's a few ways that you can support the podcast. The first way is if today you hear something from Dean and you thought it was insightful or you learned something from it, please share the podcast with somebody that you think would get some value out of it. The second thing is if you go to the podcast website, concretelogicpodcast.com, on the bottom right-hand section of the homepage, there's a little microphone. Click on that microphone. You can leave me a voicemail. And if you could leave me a voicemail, just tell me what you think about the podcast, or if you have a topic or a guest suggestion, that would be great. You can always email me too, but I thought it'd be cool to hear people. The last way is back on the homepage in the upper right-hand corner, there's a donate button. And again, if you feel like you got something out of this episode or any of the episodes and you want to donate to the show, you click on that and you can donate any amount. And just think about it like you're donating to another one of these different associations we're all a part of. There's ACI, NRMCA, there's the flooring. I don't even know what the flooring ones are, Dean. But we all pay into those. So it's like paying into that, but you get to choose how much you want to send over to the Concrete Logic podcast. Those guys don't let you choose. With that, Dean, we'll roll into our topic of today. And we wanted to start off and talk about concrete moisture vapor emissions.
Okay.
What is that?
Okay, so we'll start with the concrete world. Obviously, when like any mix design or the basic recipe, when I talk to non-concrete people, the four components, you got your sand, rock, powder, and water. And then throughout the process of placement consolidation, you have the bleed process. So a lot of that extra water from the mix is lost during the bleed process. And obviously about half that water is consumed in hydration. But throughout the concrete's life, some of that residual moisture, either from placement or from getting re-wet after placement, is going to make its way back out, which is no big deal. Obviously, we all know that concrete loves water. Concrete's happy with water. But when we try to stick things to concrete, or once we do stick things to concrete, if that moisture continues to come out, if it emit moisture vapor emission, depending on what the chemical constituency of the binding agent to whatever it's sticking to the concrete, if it does not like moisture, that vapor emission can cause that adhesive bond to fail. It could cause, now let's get back to, say, flooring. It could cause some kinds of flooring to adhesives literally to re-emulsify, go back to a liquid state. It could cause certain kinds of flooring product, let's say wood, to swell and cup and buckle. Let's go to epoxy flooring. It could cause it to literally bubble up, dome up, paint to peel. So moisture vapor emission is the residual mixed water coming out in a gaseous vapor form and then re-emulsifying or basically attacking the material that's causing the bond to the concrete, resulting in a failure.
Yeah, that when you started talking about epoxy, I just did concrete countertops in my house.
Mm-hmm.
and I did epoxy coating over the top. And one of the instructions for the epoxy, it says you got to wait 14 days before you put the epoxy down. That's to get all the moisture out, right?
That's okay. So that's a whole different subject, but a lot of products in the commercial world, most of those products say wait 28 days. And here's the crazy thing, you being a concrete guy, 28 days is the day that we want to see, the engineers want to see the design strength. So that's the 28 day.
Mm-hmm.
So a lot of products out there that are not in the concrete world will say very clearly, wait 20, it's this full phrase, wait 28 days until the concrete is fully cured, which I always hate that term, cured, until you can put your material down. And yes, they are relating, those manufacturers are relating 28 days to the concrete no longer going to emit a moisture in sufficient quantities to cause the material that's being applied to fail. But it skips a whole lot of things. 28 days in concrete terms is related to a design strength goal and not to whether the concrete is still emitting moisture. So it's like saying, well, I want to take a trip to Texas, and then somebody responding, I'm going to wear a blue shirt. Okay, it's not related. It's not in the same world. The unfortunate thing is it leads a lot of contractors and owners to think that 28 days is some kind of magical time. Think about concrete roof decks. This is especially damaging with roof decks because that concrete is exposed to the elements. So I always laugh when I hear that. And I'm like, okay, what if it rains on day 27? And then the manufacturers, they have nothing to say. They're like, well, I said, do you restart the clock? Because the data shows the concrete is going to be 100% humidified again. It's going to have moisture content again that's going to have to release. So what do you do? And unfortunately, these manufacturers don't have an answer for that. But yeah, you're right. So the 14 days is that manufacturer trying to game the vapor emission from the concrete.
Mm-hmm.
Did you have to profile it all, or were you able to just put it down on the concrete? Just curious.
Yeah, you had to sand it a bit. That's what you meant by profiling, right?
Correct. And that's to create a mechanical bond as opposed to a chemical bond. The second reason why a lot of these products, especially in the industrial world, will say wait 28 days is because the mechanical profiling is usually a bead blast, shot blast.
Mm-hmm.
And so they want the concrete to be a minimum of 3,000, 3,500 PSI before they start shooting ball bearings into it.
I learned that the hard way. So I was trying to, doing projects at home with the family involved around you and crazy 4 kids at home. So it's like a circus. That's why I didn't hire someone to do this.
You had a labor team.
I didn't have a labor team. My oldest son helped mix some concrete, so that was cool. But having the patience to work around what's going on within the house, and everyone likes to use the kitchen, so you got to work around. Kid running to the refrigerator, my wife trying to use the stove, all those different things that if you have a contractor come in and do these things, I don't know if he'll price that in his proposal
give you a change order for delay a project.
Exactly. You get how many interruptions a day do you get when you work in the Tandit house? Well, anyway, so I was trying to push the schedule. I got in there and tried to sand a little bit earlier than it told me, and yeah, it was ugly.
Oh, so the concrete itself wasn't. How early did you try to push it?
I was like, I think it was like next day or something. Just see what we would do.
Gosh.
But like I said, it's just a very. It was like a heavy paper. They just asked for a little bit. I forgot what it was, like 200 grit or something like that you had to hit it with. And I was like, maybe, but
that's all right. It starts taking off a lot more than you wanted to.
Yeah. Then they're exposing aggregate and all this other stuff, and it's like, no.
Well, it could be cool if that's what you're looking for, but
yeah.
So there you go. That's a perfect example, and maybe not a perfect example, but so if we're ever involved, we try to bring it back to the world of reality and say, well, 28 days is really a design strength from a structural engineer. They can start testing it 24 hours if they want, but there's usually a 3, 7, 14. First and foremost, you're looking for design strength for that product. So that 14 days for you may have been more related to design strength, especially because of the interior. But secondly, those products still relate it back to some moisture vapor loss that they believe that a certain amount of moisture or sufficient moisture will have been vacated from this, or emitted from the concrete, so it's not going to cause their product to debond. But when it comes to an epoxy, a two-part epoxy or two-part urethane, I put much more weight on the concrete strength profile because of the mechanical abrading or profiling or beating the crap out of it with ball bearings before applying the material.
Yeah.
So, as you saw yourself.
It's like those things you do at work. You know better at work, but then when you come home, you seem to like.
Yeah,
that's why
I was laughing with you, because I'm thinking, given your history and what you do, I'm like, I would think you would know that.
Well, it's like on a job site, we're all very safety conscious, and you got all your PPE gear on,
right?
And you're watching out for each other. And then you get home, and then you jump on the ladder and
sit on a bucket, and you're reaching.
Exactly. So I did that. That was stupid. But
so was your wife then impressed with your professional acumen at that point?
Oh, the jury's still out. It's an ongoing process.
Gotcha.
No, for my first time of doing countertops, I'm satisfied with it. I know what to do next time, and I definitely won't do it in an active kitchen ever again.
Very big fan of concrete countertops, but go back to your two-part epoxy. One of the things a lot of people separately, but this does lead to issues that get blamed on moisture that have nothing to do with moisture. I'm guessing, or it should have, that your epoxy two-part had fairly detailed or clear mixing instructions. In other words, use a certain kind of blade, a certain speed. A lot of people DIY. Well, I'm not going to blend this on low for 2 minutes. I'm going to frappe it, and I'm going to put it on high, and I'm going to make a meringue. I'm going to get this done. I'm going to mix this together quick. Well, that then sucks in air. So think about your concrete. You suck in a lot more air, which compromises what you're trying to do with the concrete in a lot of cases. So when it applies it, when it's applied, it can create a lot of air bubbles, and it actually can screw it up. The converse, though, is if it's blended insufficiently, and I have seen this on one fire station in the Northeast commercial job where the installer did not mix sufficiently, and after it was placed, the A and B components started separating, and there was a light brownish yellowish viscous substance that was oozing out of the surface of the concrete. Why this is important to your subject, your question initially about moisture vapor emission. The installer came in and blamed the concrete. Specifically, that moisture in the concrete was causing this stuff to come up. We were not involved with the project, but the concrete sub on the project knew what I did, and he reached out to me. And so I asked him specifically, tell me exactly the product. And I needed the exact names. And so I got part A and part B, and then I went to the SDSs of both products. A whole list of different chemical compounds. But I started going through each one of them, and lo and behold, one of the constituent components was described as a light yellow to light brown viscous substance. Slippery. Because the guy told me it actually had the consistency of brand new 10W30 motor weight oil. And I said, well, one, there is nothing in the concrete that's that color at all, I think, ever. Secondly, if it was, it wouldn't be coming out. So I said that the idea that this is coming from the concrete is simply absurd. Secondly, I actually researched, I said, there is a commercial warehouse that sells that exact product about an hour from you. I said, this is what I recommend. I said, go there and buy the A and B. I said, then go to a dollar store. Don't use your wife's china. Go to a dollar store and buy like 4 or 5 white ceramic porcelain plates. Disposable. You don't want to use paper, but I go on one of them, put a bit of the A and B and just haphazardly mix it. Don't mix it as much as you're supposed to. And then on another one, mix it until it's fully incorporated. And then look at it the next day. He calls me back. And he actually replicated the issue. And so they had a meeting at the city hall where the fire station was, and this whole situation starts going down, and he does his little show and tell. He brings it out. He goes, this is on porcelain. That's the exact same material. All that's on here is part A and point B. And so it went from being the concrete blamed on moisture vapor emission to being the actual issue where the material was not blended sufficiently and it started disincorporating after it was applied.
Oh,
So moisture vapor emission, whoever's out there in the world that may listen to this, concrete moisture vapor emission has become public enemy number one, and is the easiest situation to blame on basically any issue that manifests with something adhered to concrete. Like the example I just gave you, if the general contractor, if the owner, in this case the concrete sub, the ready mix producer, if they don't know, then they're going to be sitting there playing Texas Hold'em with literally no cards in their hand. And then the installer and their material supplier are going to have all the cards. So literally they can say whatever it is they want. And the other side of the table is just going to have to sit there and say, okay. But in this situation, that concrete sub knew me, and I was able to help him figure out a way to totally flip the script. And it was back on the installation company to come in and tear up this 30, 40,000 square foot. So think about the amount of dollars involved with that, with epoxy, right? You're shaking your head. Because these issues can become very expensive very quickly. Because now you've got partially bonded, partially secure. You've got a maintenance bays where you're having very heavy fire trucks parked, ambulances, and now all that has stuff to be ripped out, which is not easy to remove epoxy. So it can be relayed correctly. Because once it starts debonding like that, it's going to start tearing and opening up, and it's going to the whole floor is going to fail. So again, all that was going to be blamed on moisture vapor emission. Only because those that actually had liability or perceived liability, owner, GC, concrete sub, did not know the product characteristics that was being applied after their job was already done. That's the other insidious thing. The ready mix producer and the concrete sub had done their job. They'd done their job well. And now somebody else has come in and done something. It starts to fail, or an issue manifest, and then that later organization, later material has been able to readily, easily, immediately turn around and blame the concrete. And the culprit is moisture vapor emission.
So moisture vapor emission is a real thing. It's just at a certain point, it's not a cause of an issue, right?
Correct. And see, the reason why I say when we get involved is because the world that I've worked in for the past 15 years is to put something in the concrete to keep that moisture from coming out. So either when I get involved, it's either one or two ways. One, our product was not used and somebody wants to know what to do to help address the issue. Or secondly, where our product or product like ours was used, which was the case that I just told you in Connecticut. I think it was Connecticut, where the project is being told something by the flooring roofing side, and they're like, this does not make sense. And so they're looking for our help to push back or to figure out. Let me give you another example of how this can manifest. This was a project we were directly involved with. And let's go back to moisture vapor emission. Yes, it is a very real thing, if not addressed. And there's two major ways to address it, or I guess three. One is not, two I would argue are not cost effective. One is just to acclimatize the space, turn the HVAC on, and wait. That's not cost effective in time or money because it could take months. So imagine a GC going to a hospital group that's building a 500,000 square foot complex, 1 million square foot. Right now we're involved in like 1 million square foot project down in Miami. But yeah, these hospital complexes can be big. And telling that hospital group that they're going to have to wait an extra 4 or 5 months after the building is finished and the HVAC system is running before they can start testing for moisture so they can put the floor down. Hospitals are revenue generating facilities. So that's an opportunity cost loss. And so when you think about the value of a hospital space and what it can generate, we went to one symposium for design construction of hospital facilities. And one of the questions I led off with when I sat down with different hospital groups was, if you don't mind me asking, what is the value, what is the revenue potential of something like a cardiac OR suite? And the best answer I got that just blew me away was this young lady. She was like, it depends on how many valves are being addressed. And I was like, what? She goes, the heart has 4 valves. She was about a $250,000 valve. She, just like that.
Mm-hmm.
And I was shocked, but they know. So at minimum, $250,000 a day. So let's say there's 20 OR suites that can handle cardiac surgeries. And you're going to shut those down for 6 months?
Mm.
So people start thinking about the cost. It is literally nearly incalculable. Waiting is not feasible, time or money. Secondly, the Cadillac option is to come in and then bead blast the surface. So let's get back to carbon emission and offset potential. And now you're coming in electricity and bead blasting and silica dust. Then you got a prime, 2-part epoxy, self-level. And that can run anywhere on a low end of maybe $5 a square foot to easily $8, $9, $10 a square foot. So let's go back to that same hospital group that's got the 1 million square foot facility and says, okay, we tested right before flooring, got too much moisture. Hey, Mr. and Mrs. Hospital owner, on your 1 million square foot facility, we need another $5, $6, $7, $8 million to put your floor down. That conversation doesn't go very well. Tell that to a school board that's been saving 7 years for a bond. Otherwise, they're going to have to wait another year to open the school. Doesn't go well for the community. Or you can put something on the concrete. Now, so that's basically the 3 ways to address it. You either wait, which is time and money, you pay a lot, or you proactively address it some way in the early one. And there's ranges of options in between to 100% waterproof adhesives, but they still have an additional cost and application and ranges therein. So let me go back to moisture vapor emission being a very real issue. You can easily Google, and actually I just gave a presentation last week and somebody asked me for failed floors. And so you asked me, is it a real issue? If you Google moisture-related flooring failures, you'll see the things I mentioned. You'll see VCT buckling. You'll see mold under carpet, which is always a big scary thing. You'll see mold under VCT or sheet vinyl. You'll see buckling wood. You'll see bubbles in athletic courts. The damage is not only real from real moisture vapor emission, the damage also exists from the claim of moisture vapor emission, and then the owner being stuck with something that should never have been occurred at all. The one example I gave you where our product was not used, a competitor was used, but they came to me, the project came to me for help. There was a real case had nothing to do with the concrete. Another case, very real case, that we were involved with, it was a 50,000 square foot addition to a school in New York. Not a big community, so pretty big spend for that community. And in this community, in this facility, there was 45,000 square foot of VCT tile and 5,000 square feet of rubber tile. So most people that are not in flooring have no idea what the difference is. They're both tile. They actually look very similar. Aesthetically, they picked 2 that were very similar. Unless you really paid attention, you or I would be like, it's the same stuff. We wouldn't pay attention. Well, VCT lays flatter. It is dimensionally more stable than rubber. Rubber has a tendency to cup up at the edges, even in the box before you install it. Because rubber has that tendency, the glue you use to hold rubber down normally needs to be stronger, more solids, more expensive than the same similar glue that you could use for VCT. Now, there are glues that'll do both, but you could have a pure VCT glue, low solids, but if you use it on a rubber and it's not strong enough and it curls up, it looks like a moisture issue. 45,000 square foot of VCT, perfect, nothing moving. Literally, the VCT came into the door to the music auditorium. The tiles were touching. And the very next tile, as you walked into the auditorium, was cupping. Every tile in the auditorium was cupping. The flooring industry comes in, pulls a tile up, drops a probe. It's moisture, high humidity. That's what's causing this. We asked, well, what about the rest of the project? Why isn't that failing? Well, the failure just started here. Right. So again, and I'm glad you laughed, because even the GC was like, so it just started here, but it's going to spread to the rest of the 45,000 square feet. That doesn't make much sense. So we went to the project, and very simply, we asked clearly what glue was used. And right there in front of the GC, my business partner called the manufacturer of that glue, asked them, say, I'm on a project where we got some VCT and some rubber. Can I use this product? Absolutely, it's great for VCT, but no, you cannot use it for rubber. It's not strong enough. And in fact, we do not even make an adhesive for rubber. My business partner said, thank you very much, hung up. That was on speaker. He looks at the GC. He goes, this is not moisture. This is the wrong glue for that kind of flooring. And he said, most likely, the installer was on site, was spreading glue. The tiles looked the same, never even realized, and just kept on going. But the failure that manifests, that cupping at the edges, looks exactly like what would occur if it were moisture vapor emission. But yes, moisture vapor emission from concrete is a very real thing. And part of the thrust of what I try to teach people is, don't wait till you're ready for flooring or roofing to talk about moisture vapor emission. Talk about it in design. And let's go back to your world and concrete world. One of the things that the message has been slow to take off is the ready-mix industry, is that value add opportunities really can affect the bottom line for a ready-mix producer. This world of moisture vapor emission is one of them. There are a number of products they can be involved with, that those products carry the warranty against vapor emission, that can help the ready-mix producer protect themselves, but also add to their bottom line. The earlier you address any issue in a project, usually the cheaper it is, as opposed to waiting to the very end. It doesn't matter what, especially like say a design issue. Oh, I didn't want that wall there. Well, that's going to be expensive, as you put it. Right. The same thing with moisture. If you address it early in design or construction, it changes overall how the whole project can approach dealing with this issue. The GC then knows that it's been handled, as opposed to let's wait and see, which can have catastrophic timing and cost implications. So yes, MVE is an issue if not addressed, and there are several ways that it can be addressed. So regardless, GCs, concrete subs, ready-mix producers, if you're on a project that's going to be enclosed and receive flooring, be part of the discussion early on, bring it up. So if an issue does manifest at the back end, you can be on record of bringing it up and then saying, okay, don't invite us to those meetings about why the floors failed.
Yeah. So you're saying a possible proactive approach would be to give, say you're pricing a project and say, I have a concrete mix that has a admixture in it that can mitigate the NVER ahead of time, right?
Yep.
And say, hey, I got here's an option for you. If we use this concrete in the area that's receiving flooring or epoxy or whatever, if we use this concrete mix, you can put flooring down in 14 days versus waiting whatever the flooring.
We've done exposed roof decks as early as 5 days for concrete placement.
Well, there you go.
Yeah. So actually what you said was absolutely 100% correct. So I'm going to repeat it, because the one thing that I like to try to remind ready-mix producers, this is no different than in hot weather, you providing your hot weather mix design with a line item for ice. I don't think producers give away the ice. Right?
No, it's very expensive. So we tell that's why we pour at 1 and 2 o'clock in the morning instead.
Because a company like yours especially doesn't want to pay for the ice or
that's
nitrogen, or we're going to inject nitrogen into it. So that's a perfect example. Or let's go to cold weather. They have a line item on there. I can give you hot weather. I can give you hot water. I can give you an accelerator.
Mm-hmm.
So this thing with moisture vapor emission, I cannot stress enough. And liability comes up, but I want to touch on this for the producer. Like you said, here's a line item. Here's my mix for your interior slabs on ground. Here's my mix for your elevated slabs, whether it's slab on metal deck, whether it's structural lightweight, whether it's normal weight, whatever. To have a line on there, I kind of joke, is like saying, do you want to supersize that, or you want fries with that shake? Is like, do you want to be able to install your floor on time, or have a line item on there that says very clearly, here's the upcharge for a warranted flooring roofing mix. And then the producer's like, well, we don't want to take that liability on. I said, well, that's not the case. That warranty is covered by that admix that provides that product. But look at it this way. If they being whoever's buying the concrete from you, whether it's the sub or the GC, says no. And then later on down the road, a situation manifests where the moisture is not, the moisture readings are really high. And I'll give you an exact example of this one I'm talking about here in a second. Then when those meetings occur about why they can't install their floor in time, you can politely decline to attend. And for anybody out there to think this doesn't occur, I'll give you an example. I will not mention firms. This was in Ohio, about a 300,000 square foot commercial office building, lightweight, and it was already like 5 months behind for flooring. So we talk about cost. Now, the organization that was moving into this building had office spaces all around the city anyway, so they couldn't move their people. And then I asked, when I present architects, I'm like, how much furniture is necessary for a 300,000 square foot building? What's the lead time? They couldn't take delivery of that material. It had to be sitting somewhere in a warehouse. So in logistics, we call that demurrage, paying for storage for stuff that you can't take advantage of right now. So that's sitting somewhere. Those people thought they were moving, and now their life is in flux. So the question was boiling down to where it was a very well-known owner in that city. Actually, if I sang the tune, you would know it. Leaning heavily on, everybody was circling around to asking the ready mix, what is taking it so long to dry? And I happened to be in town talking to that producer, and I said, well, heck, I said, if he goes, they have a meeting every Tuesday. I'm like, well, if they'll let me, I'll go over there and talk to them. One of the saving graces was that producer had offered, just like you said, Seth, they had put that down. They had said, hey, we have an option for you to address the issue of moisture. It was said no. So then I went through and gave part of the presentation. The owner's rep was there, and he paraphrased when I was done. He's like, basically, we were, I won't use that word, but basically, we had no hope of passing this test from the beginning. And I'm like, he's like, so what you're saying is we had no hope of passing this test from the very beginning. I said, sir, I'm telling you what ACI literature says. I'm telling you what ACI 302.2 says. I'm saying what literature goes back 20 years says. I'm just the messenger. I said, I'll send you the base documents. I said, the concrete industry is known forever, and the flooring industry, that most likely you won't pass this test. So the idea that providing a product like this is going to accrue liability to your producer, I would offer that it will actually do the reverse. So if there's an issue, a failure occurs, or an issue where it doesn't pass a test prior to installation, which I still see as a failure because it affects the project being able to be completed, this would actually help protect the producer or protect the concrete sub should that manifest.
How many of those issues are related to not properly testing for moisture?
Wow. But that's a very skewed thing right there, because we could have a whole discussion just on the moisture test itself. And let me tell you, the main moisture test is called ASTM F2170. You're a smart guy. You deal in square footage. Think about a building that you've done. Give me a decent sized building that you've been on, square footage wise.
1 million square feet.
That's a lot. If you're out there, you can visualize the surface area, right? That's a lot, right? The standard says 3 for the first 1,000 square feet, and then 1,000 square feet after that. So in that 1 million square foot, you're looking at 1,002 test. Okay. the size of the test is less than the diameter of a quarter. What percentage of the surface area are 1,002 quarters going to cover of 1,000,000 square feet? Not much, like 0.000 something percent. The reason why I go through that is because the standard says very clearly the only area being tested is directly at that location. So 1 millimeter over is not tested. Secondly, the result is only valid for the point in time of the test. So as soon as your brain recognizes or registers that result, it's old. It's no longer valid. Third, and this is within ACI 302.2, the Concrete Society, so I guess Britain's ACI, going back as far as 2004, has established that the relative humidity of concrete is not related to the adhesion of resilient flooring. So here we have a test that's point in time, less than a diameter of a quarter per 1,000 square feet, not related to adhesion. So, and most likely not passable because of what the concrete is exposed to. It doesn't really start drying. This was also an ACI. This is an ACI article, Concrete International. This would have been in January 2012. There was a whole article. They did a longitudinal test of how long it takes concrete to dry. They tested for like 13 months in an exposed working warehouse, not HVAC, doors open in the daytime, closed at night. And they also did it shortly thereafter, 7 months in a completely enclosed space. And even with 7 months going of the RH probe in the concrete, it never got below the levels required for flooring. And then ACI 302.2 says it's the last wetting that starts the drying cycle. Well, in that 1,000,000 square foot slab, when was the last wetting? Wasn't until it was enclosed. And even then, well, what about dew point? If that space didn't become acclimatized, it still went through some wetting cycles. So now the clock doesn't start until the HVAC is on and you're controlling the humidity. That's when the clock starts. So even if the test is done correctly, what relevance does it actually have to a successful flooring install? So for the past 20 years, not related to adhesion. And again, another subject we could discuss is warranties. Every product that requires these adhesion tests or requires these RH tests, in their warranties, they exclude moisture. So then what value then, even if you do the test correctly, does it have to the owner of shifting their liability? So it's a whole process thing. It's not just, and everybody wants to go back to the test. So if the test is done correctly, so what if it is? It's point in time, exact location. So unless the failure manifests right above that probe, which is highly unlikely, the simple answer is that area wasn't tested.
Mm-hmm.
So there you go. This is not like C39. This is not like C39 where people build 100-story skyscrapers based on the results of C39. This is not like that. So a lot of times the concrete world thinks about C39 as being an established, accepted test amongst other concrete tests. We got the air and slump and things like that. The moisture tests aren't like that. It's not the same kind of thing. There's no shift of liability. There's no requirement to perform from those tests themselves. And there's no warranty that then goes back up those results.
I think the best way to do it is be proactive and address it ahead of time, which is a common discussion point on a lot of the topics we talk about, is getting ahead of it.
If you're doing a job during cold weather, don't you guys have a cold weather plan?
You submit all that stuff ahead of time.
Well, there you go.
So,
if you're hot weather, well, curing should always be discussed, but anybody placing concrete that does not go through some kind of curing discussion almost daily because ambient conditions change, wind speed, evaporation rate, that doesn't go through that is probably looking for bad things to happen.
Mm-hmm.
Moisture is the exact same thing. So the concrete world needs to be having this discussion way up front like that and really benefit from this issue as opposed to leaving to other industries that then turn around and blame you anyway.
I think making sure that folks are addressing this ahead of time and not being dependent on a moisture test. If you use the right approach or products or whatever, the moisture test sounds like it's shouldn't even be in a discussion.
100%.
That's the goal.
Absolutely correct. Yep. So again, process change, you do a process change, a product change. If you address it correctly early enough, you can actually eliminate the entire need for the moisture test, totally changing the power of the GC to keep in charge. And so one of the things I've started talking about is how it changes project delivery. And I've had hospital GCs now tell me, so if we address this correctly, we can actually use this proactive approach of moisture as a competitive advantage to delivering our projects. That's how powerful this is. That's why the concrete world needs to be up front and bring it to attention way early on, just like you guys do everything else.
So if you heard that and you're interested in learning about that, you need to reach out to Dean. And Dean, what's the best way to get a hold of you?
Well, I can give my phone number right now. You can call me, or I can give my email, or how do you want to do it?
Oh, that's fine. Or I can just share it in the podcast.
Please
notes.
share in podcast notes. Seth, please share my direct cell and email address. Would love to hear from anybody out there, and if we can assist, be glad to.
Yep. And so we'll share that info on the podcast notes. And if you have a hard time getting a hold of Dean, reach out to me. I'll get a hold of Dean for you. But Dean, I appreciate you coming on the podcast again. I think this is something that's got to be discussed more.
Yeah,
often.
I love it. Thank you very much for having me back. I was tickled and very pleased and glad to be here.
Yep. Appreciate it. And folks, until next time, keep it concrete. And that concludes another episode of the Concrete Logic Podcast. I hope you got some value out of that episode and learned a thing or two. If you did, visit our website, concretelogicpodcast.com. Click on the Show Support tab and learn how you could be listed as a producer of an episode. Again, that's concretelogicpodcast.com. Click on Show Support tab to learn how you can support the show. And as always, Mike Dunton will take us out.
Ring, ring, that alarm always sings. Couple hours before the sun comes up. Open up the side, put some diesel in the lights, and wait till the trucks roll up. Yeah, this ain't how most folks live their lives. Dripping in sweat, working overtime. But while they're tying their ties for their 9 to 5s, we're out here changing these skylines with wood, iron, and mud. We work hard for $1, give thanks to the Lord above. Never make a man do something you can't prove. Hard work calls for a drink or two. Expect more, it's written in our blood. With wood, iron, and mud. From the swamps to the city, from the Lone Star heat to the woods of the Georgia pine. Good old boys and girls who ain't afraid of getting dirty for a clean time. And if you want to see the fire in a grown man's eyes beneath the hot summer sun, find the wild-eyed boys clocking days and nights, working hard to get that job done with wood, iron, and mud. We work hard for $1, give thanks to the Lord above. The color of our collars ain't white or blue. We're all gray collar through and through. Expect more, it's written